Okay, so today we're going to talk about the blood, the components of the blood, red blood cells, how they're removed from circulation, and what happens to it after that. And then we'll go into this last thing right here, talk about coagulation. Okay, so starting with the composition of blood. So we'll come up here. So the composition of blood, if we were to centrifuge the blood and get it to separate into all of its different parts, we would see something that looks like this. So we see this. First, we have the red blood cells. They are the heaviest, I believe, which is why they're at the bottom. We got red blood cells. And then we got plasma, which makes up, I think, about 55% of our blood in general is plasma, 55%, which is made up of like 92% water. So lots and lots of water in the plasma. Plasma contains something very important called albumin, and albumin is a protein. And it's got some other nutrients and electrolytes and things like that. But I think the biggest thing is albumin and water. But and then this buffy layer right here, this middle layer, that is made up of white blood cells and platelets, which we would talk about platelets later. So the ratio between red blood cells and the rest of the blood is called hematocrit. So that ratio is the blood to plasma ratio. So again, this part in ratio to that part. Okay. So let me check what's next. So the composition of blood includes the components of plasma. Yeah, okay. Describe the mechanism in which red blood cells are broken down. Okay. So red blood cells, if we take this chart here, so red blood cells are made in the bone marrow. So they're made in the bones, and there's these things called reticulocytes that are kind of immature or not fully matured red blood cells. Those are released into the bloodstream, and they are able to mature fully into red blood cells. Then those red blood cells last about 120 days, and then they are not really useful anymore. We're making like millions every second, so it's fine. We get rid of them pretty quick. Anyway, so 120 days, then they're done. They circulate through. And then macrophages are swallow or like eat these old red blood cells. They are found in like the spleen and the liver, and I think in bone marrow as well. So they're eaten by these macrophages, and then it's broken down into its different parts. So the different parts it's broken down into is just the cell components in general, and then hemoglobin. So hemoglobin comes out. Hemoglobin is the main protein in red blood cells. Hemoglobin comes out, and we can think about hemoglobin in two parts. So we can think about the heme part and the globin part. So the globin part is basically just recycled into amino acids, and it goes back into the process of making more red blood cells. And then the heme part is made up of a couple different things. So heme is made up of heme groups, and then also iron ions, this big iron ion in the middle. Those are then further broken apart. Iron goes to transferrin, and then transferrin gets converted into ferritin, which goes and does things in the liver. I think the main one we need to focus on more so, that we talked about more in class, is where the heme group goes. So the heme group will be broken down, and it will get converted into biliverdin, and then biliverdin will get converted into bilirubin, which will be in the liver. And then I don't think I need to talk about this too much, but basically bilirubin gets converted into conjugated bilirubin, goes into the bile, that goes into the intestines, and then it gets changed into urobilinogen. That can then cross the bloodstream, so it can come up here go back to the kidney, or it can go back to the liver, or it can go back to the kidney and get changed into urobilin, which is yellow, which makes our pee yellow, or the conjugated bilirubin that stays in the intestines, again, gets converted to urobilinogen and then gets converted to stercobilin, which is brown, which is why our feces is brown. That's about 50%. Anyway, I don't know how much I need to talk about that. I didn't say it too much. How heme is broken down. What happens to various components? Okay, yeah. I think that's pretty good. Now, going on to hemostasis. So there's 3 steps of hemostasis. So there's vasoconstriction, platelet aggregation, and coagulation. So we're going to go through this. So basically what happens, real quick, is that, okay. So first we have vasoconstriction. So if you get a cut on your arm, the first thing that's going to happen is pain receptors are going to cause the vessels to constrict that are going to cut off blood flow temporarily. But that's only a temporary fix. It doesn't fix it long term, which is why we need the other steps. So we have vasoconstriction that helps for a second, but we need some other steps. So then we have these little platelets in this next step that involves platelets. So we have these platelets, again, found in the Buffy layer. These platelets have these little sensors that are VWF receptors. And VWF is basically just something that's released from the endothelial cells. So it's released from there. When we cut all these endothelial cells up, VWF gets released. It comes and binds to these receptors. Something else that, scratch that. So VWF binds to the receptors, and then VWF has a strong affinity for this collagen. So this, with the VWF on here, it's going to go up to the collagen, bind, and then this binding process is going to activate this platelet and cause it to change shape into something that looks like this. Okay, now pausing there, something else that can activate platelets is ADP. And anyway, so VWF, ADP both activate platelets. Something else. So activated platelets have these granules, and there's different kinds of granules. There's alpha granules, and there's dense granules. Then they release different things. So this dense releases ADP, which further activates more and more platelets. VWF is released from alpha granules, which activates more of these. Also, activated platelets release TXA2, prostaglandin, which also activates other platelets. So you get these 3 different things that activate platelets, and so this kind of is a big cascade. However, these endothelial cells, they prevent further. They prevent this cascade from going on for too long. So thankfully, there's some regulation here. Anyway, so these are activated. We got a bunch of them. And then, once they're activated, they have these new receptors that are called, this long name, I don't care to say that. We don't really care. We just know that it binds to fibrinogen. Fibrinogen is made in the liver. It comes and binds to these new receptors, and these new receptors with the fibrinogen are now allowed to bind to each other. So when they bind to each other, they are going to go and block the wound, or where we're exposed, where we're bleeding, where we got the cut. So all these bind together, and all these activated platelets bind together, and they help form a little covering to cover up the bleeding and cover up that cut. So that's the second step. The third step, which is happening at the exact same time as the second step, this is happening simultaneously. So what happens is that we have this cascade. So we have various factors. So what happens, or let's see, the ultimate goal is to make this thing called fibrin. And fibrin is something that holds all those platelets. It holds red blood cells. It's basically what holds your scabs together. If you look at a scab, it's kind of wiry. It's got like little strands. That's fibrin. Fibrin is that. It holds everything together. So the goal is to make that. And along this cascade, we are just exponentially multiplying all this stuff. So this cascade involves a few different pathways. Intrinsic, extrinsic, which both lead to common pathway. So starting with extrinsic, we start with these different factors. The first one is Hagman factor 12. This is closest to the little wounded site. And it gets converted into factor. I'm just going to use numbers, but they're all factors. Factor. And then they get converted into enzymes, which then convert factors into enzymes. Anyway, so factor 12 gets converted into 12A. This new enzyme can convert 11 into 11A. That converts 9 into 9A. That joins with factor 8. That converts 10 into 10A, which combines with 5. And then down here is where I'll stop there. Up here, at an extrinsic pathway, we have some more factors. Factor 3 changes 7 into 7A, and then that changes 10 into 10A. Now we see in both these cases we have 10 and 10A. So 10A is going to come down here, join as part of this. So it's like a double whammy. We get 10A and 10A from here, which even more so increases the amount of fibrin that we're going to be able to make. So 10A combines with 5, and then we make some very important things that we were told to remember the names of. So make prothrombin, and it gets converted into thrombin. And thrombin then is able to convert fibrinogen into fibrin. And again, this final product is what holds everything together. That's how coagulation happens. And it's called a cascade because we're multiplying exponentially. Okay. So coagulation, platelets and coagulation cascade. For the coagulation process, interesting common pathways. Okay, now finishing off with TPA, plasminogen, and plasmin. Okay. So, TPA. So these are all very related. So basically, TPA is okay, let me make sure I'm getting this right. TPA, that's right. Okay, I remember now. TPA is a protein that turns plasminogen into plasmin. So it's kind of like this activation. So TPA turns plasminogen into plasmin. Plasmin is the activated thing that goes and breaks down this clot that we've made, this clotting. And so that is important for when the body heals. We also use like actin and myosin. The clot with actin and myosin is gonna help it contract more and get smaller and smaller and smaller until plasmin comes in and just eats up that clot, so that we don't need the clot anymore. It eats it up. We don't have to worry about it getting in our bloodstream because plasmin comes and eats it up. So that's the role of TPA, my bad. TPA, plasminogen, and plasmin. That's to break down the clots. Let me make sure I got everything. Yes, I think that's about it.